Hello and welcome to another video of this series of videos that we are uploading. This is the video on functions, and last time we had left off at this point, and this exercise was state in words the rule defined by the following functions. For example, uh, mm, this f of x is equal to 6x. F of x we can write y at the place of f of x, right? So f of x means the output. This left hand side is the output, and 6x, uh, it x is the input, and it multiplies the input by 6, and the output uh, comes out as 6 times the input. Okay, so as we have written, multiply the input by 6. So this function multiplies the input by 6, and the output comes out whatever input you may give to it. Okay, so now let us move forward. This will be a short video, inshallah, and this what this is, I have written a question over here. What does the question read? It reads as follows: write down the function which can be used to describe the following rules. I already written this one. The rule is given. We have to write the function in mathematical form. Square the input. Okay, we have to square the input and divide the result by 7. Sorry, use the letter x for the input and f to represent the function. So we have two things here: f to represent the function, x as input. So as an answer to this question, what would we do? We would write f of x, because f represents the function, x is the input is here in the brackets. Okay, uh, we could write anything in place of f of x. Y is equal to f of x, or anything, but this function is represented by f here, and x is the input, so meaning this function depends on x. Okay, is equal to square the input, meaning input is x. Okay, square this. What's next? And divide the result by 7. Divide by 7. Okay, this is very simple. And now let me write the next question. So here we go. This is the next question. Divide the input by 3 and add 7. Call the function g and call the input t. So as an answer to this question, what we would do, uh, first we see this, what call the function g. Okay, function is represented by g. Okay, and the input is t, meaning it depends on t. This this naming doesn't matter at all. We can add y at its place, whatever, z at its place, whatever, it's meaningless. Okay, uh, but since we are using t as an input, we have to write this in brackets, and g is the name of the function, to represent it. This is equal to, meaning output is equal to, what do we have to do to the input? Divide the input by 3. What's the input? T divided by 3. Okay, and then add 7. Okay, plus 7. This is the answer to this question. So far so good. So here we have another question. This is a separate question. State the rule of each of the following functions. This, here we have the mathematical form given, and we have to state the rule. Here this function is represented by f, the input is t, and the output, what's the output? Meaning, how do we find the output? By multiplying the input by 5. So what would we write as an answer? We would write what like this: multiply the input by 5. That is enough. So I wrote this: multiply the input by 5. So we don't have to write this call the function f and input t. Okay, this isn't necessary at all. Okay, and let me write another question of this type. Okay, this is another question. F of x is equal to 8x plus 10, meaning we call the function f and the input is x and the output, what's the output? Output is multiply the input by 8 and add 10. Very simple. Okay, then it's simple. We don't have to write call this function f and call the input x. This is not necessary at all. Now here is another question. This is a bit important. Here this we represent this function by f. Okay, uh, and x is the input. What would we write the answer as? The answer is as follows: add 1 to the input. Look, 1 plus x, add 1 to the input, and then what we do is divide 1 by that entity. You are you getting my point? Add 1 to the input and do what? Divide 1 by that entity. It's not that divide that entity by 1. No, it's the opposite. Divide 1 by that entity, or you can say add 1 to the input and reciprocate it, and then reciprocate it. That's very simple. So I think I will write add 1 to the input and then find the reciprocal. And here this function is not defined at x is equal to -1. This should be kept in mind. At x is equal to -1, this function is not defined, and we would, I think, I don't know if we have read that already. I don't know. Let me check here. Here is this what we have written previously. No, I don't think. We'll get to that, inshallah. So this is we are formally now starting the second topic of this of this chapter, functions. This is called the argument of a function. Okay, this is a very, very small topic. Inshallah, it would be covered in, I don't know in how many minutes. I don't know. Let's see. The input to a function is called its argument. This would be very, very clear by examples. The input is called its argument. This looks like you know. I mean, you can uh, uh, you can draw a lot of meanings from this. You can say, what does this mean? For example, is f of x, for example, if x is the input, then then would we call x the argument? If t is the input, then would we call t the argument? If, for example, p is the input, would we call p the argument, etc. We would see in examples. Okay. uh, for for uh, for now, you should remember the input to a function is called as argument, and in the following examples you will understand clearly what argument is, very very clearly. There will be no ambiguity, uh, so it will be very clear what the argument is. I would now write some examples to make it clear what argument is. This is the first of many examples. uh, G of t is equal to 3t plus 2. For example, uh, find the argument, not the argument, find the output when the argument is 4. Okay. Now you may have gotten an idea what argument is. Find the output when the argument is 4. You should consult some notes also. I also consult notes of um, that those notes are called HELM. I don't know the full form. That is from England, from somewhere, Sheffield University, I think. Find the output when the argument is 4. So we would write it as follows: G of t is equal to 4 is equal to uh, 3 into 4 plus 2. So this is equal to 14. Okay. 3 4s are 12 plus 2. This is very simple, as simple as this. And we can write g of 4. Okay, g of 4 as well, because 4 is the argument can be written in brackets, is equal to 14. For example, we have to find g of 7. G of 7 is equal to 3 times 7. 3 times 7 plus 2. 21 plus 2, 23. So this is what it is. Okay. Another example we have been given. F of x is equal to 3x plus 1. Look, I haven't got a proper studio or anything like this. I'm taking this video, I'm by my phone. There's no no good camera, etc. This thing, and this, my hand is shaking, so I'm sorry for that, and I'll try to get something at least, and that would keep my phone stable. Okay. Now we have to find in this, if uh, a part, f of 2. What does f of 2 mean? Find the output when the argument is 2. So we would write uh, f of 2 is equal to 3 multiplied by 2 plus 1. Okay, f of 2 is equal to 6 plus 1. So 6 plus 1 is 7. Okay, for example, f of minus 1, so here the argument is minus 1. So minus 1, if the argument is minus 1, we would write f of minus 1 is equal to 3 times minus 1 plus 1 minus 3 plus 1, that is minus 2. Also, this is the answer to this question as well. So this is the page. So in this we are given this thing, g of t is equal to 6t plus 4, and find the answers for argument 3 and argument minus 2, meaning for input 3 and input minus 2. So for 3, g of 3 is equal to 6 times 3 plus 4, meaning it is 22. Very easy to calculate. And g of minus 2, this is some basic math. G of minus 2, this is below the high school level, I think, or maybe at par the high school level if some people have not read functions. G of minus 2 is what? 6 times minus 2 plus 4 minus 12 plus 4 is minus 8. Okay, so this is the look at this whole page. Now we would go to in this argument topic, we would go to some important things now. I mean, this is the most important thing in this argument topic, and if you understand this, then this argument will become very very clear in your mind. Then you don't need to worry what argument is, etc. Then you'll you'll be very good at this. Okay, for example, this is one of the most important examples. Y of x, this is a function is called y, and x is the input, is equal to 3x plus 2. So what we have to do here is we have to find we have to find values of this function at some different inputs, meaning at some different arguments. We have to give it some arguments, and we have to find outputs. Then find y of t. Before we would we would do what? We would do, for example, y of 5, y of 7, y of 3, y of minus 40, anything. So numbers were arguments, but some these variables can also be used as arguments. So y of t, what is y of t? Is equal to 3t plus 2. Replace this input by t. So okay, khalas, done. So this is done, finished. And if you understood this, then you don't need to worry about anything. You have understood arguments. Some more examples. So this is y of t. This is not function of t, meaning this is the what this is an answer to I mean answer to the question that the the function is y of x is equal to 3x plus 2. Input is x, but the argument is t here. Similarly, we can write, for example, mm, another question. We have to find y of 2t. Give the argument 2t. Okay, so it is 3. So in you would replace x by 2t, as simple as this. Okay, plus 2. 3 multiplied by 2t plus 2, so it would give us 6 times t plus 2. So y of 2t. So this must be very, very clear now in your mind that what argument is. So is this clear now? This must be clear. You can pause this video and write this on your notebook. This must be written because when you write, you understand better. Okay, now this is y of z plus 2. So very easy. Similarly, y of z plus 2, what would we do here? Replace x by z plus 2. 3 times z plus 2 plus 2. This would give us y of z plus 2 is equal to 3z plus 3 times 2 is 6 plus 2. This is the answer. We can write it as 3z plus 8. Okay, now this is another very important example. Then it will be very clear to you. So to make it very, very clear that functions are I mean they are very, very easy if you remember these rules in your mind. If you keep these rules in your mind, you don't have to complicate things, etc. Think 10 times what am I doing, etc. You have to keep these things in mind, and then you can move forward like a boss. You don't need to complicate things. Now look, if I give you an example, uh, y of 5x. Okay, looks like that this 5x is uh, this here we find x, and in the original function also we have this x, note x as the input. So this argument is also argument also contains x. Okay, so this looks like functions are complicated. No, functions are not complicated. Do the same thing when you keep the rule in mind. Don't complicate things. Do the same thing, meaning we have to keep in mind this is not the or this is only the argument. This is not what the original function is. This is only the argument. Okay, y of 5x is equal to 3 times, replace the input by 5x plus 2. Okay, y of 5x is equal to 15x, 15 times x plus 2. Okay, so when you don't complicate things, keep the same rule in mind. No matter what comes, no matter what comes in front of you, you can deal with it. Okay, so functions are very easy. Keep these rules in mind. Whatever comes before you, you you can you can solve that very easily. Look, here it is, written via 5x. 5x is the argument, and you the input is the input here is x. So the input here is x. In place of this input you put what? 5x. 5x as the argument. So the value of the value, I mean the output the output of this function at uh, at input at input 5x is this, meaning the value of this function at input 5x is this. Okay, so what do we conclude from this? From this we conclude that it is quite possible to obtain the output, to obtain the output, meaning to obtain the value of a function, uh, even when the the input is an algebraic expression. So look, the input, meaning the argument, in all these cases was an algebraic expression. Look, uh, see it for yourself. For example, in this, uh, you know mm, the input was t, meaning t is an algebraic expression. Input was 2t. Input was z plus 2, and so on. So these inputs were algebraic expressions, and we still were able to find the outputs. Okay, so we would continue this argument in another lecture. That would be a very small one, I think. So for until that time, it's goodbye. See you soon, and please subscribe to our channel and like this video if you liked it. If not, then still like it. Okay, goodbye.